Ready whenever you are. Okay. All right, everyone. Welcome once again to your study part, where we bring you academic excellence at an affordable, cheap rate, even at the comfort of your homes. Today, we get right into what we have. The subject remains physics, and the focus remains multi-choice questions that has a twist of options, whereby you are detailed in your thinking in order to choose your answer. All right, so to get started for today, I would like to call your attention to the fact that we have just about 1 month to go before we have our less than 1 month before we have the UTME examination for this year. And as such, I want to appeal to you. This 1 month, you can make it count just by subscribing at a very affordable rate, 7,500 naira, and you're good to go. And you can still make your jam for this year count. A success is what you are, and that's what we want from you. So let's get right into it. We have questions that require you to what? Think carefully in your UTME examination. Remember, 40 seconds is all you have for solving questions. Let's look at questions I'm talking about. The first question of the day. So we are looking at UTME question tags that have option I to IV, from which you select the correct answer. The first question goes thus. Number one for the day. We have I saying this. Thermometer must be vertical. I says top of mercury. Top of mercury. The third option says air must air used must be dry. So, this question is saying, which of the following, which of the following precautions are common? Which of the precautions are common in verification of Boy's law, Charles law, and pressure law? So option A has it, that is it I and I. Option B has it, that is it I, and I. Option C has it, that is it I, and I. Then the last option, D, says I and I. Now, looking at all this, we have various options before us, and we have to be careful in picking our question. Remember, time is not on our side, so we cannot dwell too much on one question. 40 seconds it is. In our own case, we'll be targeting 1 minute for the explanation as to why we are picking answers. Whenever we are talking about Boy's law, Charles law, and pressure law, there are certain things you want to put in mind in terms of the precaution you are taking. Remember, for Charles law and pressure law, for Charles law, you are having volume in relation to temperature. For Boy's law, you're working with PV being equal to P2V2. Here, for Charles law, you're working with volume with respect to temperature. For pressure law, you're working with P1 over T1 being equal to P2 over T2. As such, among all of these, you have that what all the general laws in terms of determining the volume, you should always, in the case of pressure, you want to work with air being dry. Why? For the instance of pressure, it's expected of you to note that what the gas is what we consider. And as such, air that is used must be dry in order for pressure law to be applicable. You are reading change in temperature relative to pressure at a constant volume. For that to be possible, the air you are considering should always be what? Dry. And that's why this is a precaution that you should take anytime you're taking into consideration carrying out Charles law and pressure law. In the instance of the top of the mercury meniscus being red, you're making reference to what? Charles law. You are taking into account Charles law. Why? Charles law, whenever you are reading your mercury, your thermometer, it's expected that what? The mercury has a meniscus, which is represented by the small letter n. The upward end of the meniscus is what you are reading in your thermometer. Note, the upward end is what you are reading in your thermometer, the upward end of the mercury. Remember, this represents mercury, whereas if you are dealing with water, for water, you are expected to read below the what? Meniscus. You are reading the bottom of the meniscus. Whereas for mercury, because of its shape, you are expected to read the top of the meniscus. So whenever you are to determine Charles law, taking into account measuring temperature with volume, with respect to what? Volume, is expected to consider what? Reading the top of the meniscus. Now, the final one. Normally, you would have that what the second option should also apply to Boyle's law. But we have that number one is peculiar, very, very peculiar with what? Boyle's law. And something was said there with regards to the thermometer, that the thermometer must be vertical. And this is a violation to the application of what? Boyle's law. When you are considering three case scenarios, application of Boyle's law, considering three case scenarios. The first case scenario is this. You have your barometer. Remember, your manometer and your barometers are both used for measuring what? Pressure. In this case, a barometer that has a vertical alignment, inclination, you would have that what? When you have a thread of mercury, it is assumed that the total pressure you want to measure, if this is your mercury, it is assumed that what? The total pressure in this case is equal to atmospheric pressure, which I call PATM. Atmospheric pressure and the pressure considering the mercury. So this is for what? Vertical inclination. But it does not stop there. When you are considering Boyle's law, you can always have an horizontal inclination. You can always have an horizontal inclination in order to determine the total pressure. You can always have an horizontal inclination. Horizontal inclination. And in the case of horizontal inclination, we always take it that the total pressure considered anytime you're making reference to horizontal inclination is such that the total pressure will be equal to what? PATM, the atmospheric pressure. PATM equals atmospheric pressure. Or you have the last case scenario. Or you have the last case scenario whereby you have an inverted tube. You have an inverted tube where you have your thread of mercury. Atmospheric pressure is acting this way. This is mercury. In this case here now, inverted vertical inclination. Although this is a vertical inclination, you have it inverted. As such, we always take it that what? The total pressure for this condition, total pressure in this case is equal to the pressure of the atmosphere minus pressure of mercury. So we subtract in this case. For the first one where we have an upward inclination, upward vertical inclination, you have addition of the atmospheric pressure and mercury. So this question is tricky. Why? They are emphasizing the application of Boyle's law. The three options here are portraying some precautions to be taken in the case of pressure law, some precautions to be taken in the case of Charles' law, and some precautions to be taken in the case of Boyle's law. When you are emphasizing pressure law, you should note that what? The air has to be what? Dry. Air has to be what? Dry. Standard temperature and pressure. Remember that. When you are making reference to Charles' law, then you expect that what? The top of the mercury meniscus should be red, and this is it indicated here. Top of the meniscus should always be red, which is very correct in this case. The first option, option I, is where we have it all wrong. You choosing that, then you get to miss it. And the reason is that what? As far as your barometer in this case is concerned, you have it that what? Barometer can always be measured horizontally. And also your thermometer does not necessarily have to be what? Vertical. In the sense that a clinical thermometer, for example, how do you get to measure your body, the temperature of your body? You place the thermometer where? Under your armpit, isn't it? Most times, the local traditional ones which we have, you have that what? It is placed under your armpit. In what position? Horizontal position, isn't it? So you don't have it that what? Your thermometer must be vertical. No precaution covers that. So talking about these three guys, you have it that what? You can always have an horizontal inclination, for example, under the clinical thermometer, or with reference to what? Boyle's law. You can always have your thermometer placed horizontally. So that's why we are having that what? In this instance now, these two options are correct. This option is not correct. As such, option C would be the correct answer. Option C would be the correct answer. On to the next one quickly. Remember, it is knowing why the answer is the answer. That's what makes you pass Jamb very well. You should know why you are choosing the answer for which you are going with. Clinical thermometers placed under the armpit would not necessarily be placed vertically. So the next one quickly. You have this. We want to test your color, your ability to observe color deviations. We're told that the angle, yes, we're told that the angle of deviation, the angle of deviation of light of various colors. The angle of deviation of light of various colors passing through a triangular glass prism. Triangular glass prism increases in the order A. Do we have it as red to green to blue? Or do we have it as option B, green to violet, then blue? Or do we have it as blue, then red, then green? Last but not the least, option D. Do we have it as blue, then green, then red? So in terms of deviation, how do you have your what? Your light being deviated when incident on a glass prism, triangular glass prism. So this is talking about dispersion of light, if you can remember the topic, and also emphasizing the color variants which we have under Roy Give. Roy Give. We are talking about red, orange, yellow, green, blue, indigo, and violet. So thank you very much for those that followed us through. You can now see, based on the arrangement, we have increasing order of deviation. This is how you have them being deviated. You have that the lowest deviation occurs with what? Color R, which is what? Red color. The lowest deviation occurs with red color. We have that the highest deviation occurs with what? Violet. That's why among all the 7 colors, among the Roy Give colors, we have that what? 3 colors were selected: red, green, and blue. So they're asking us in what arrangement, then Violet as well. In what arrangement do you have these guys such that what? You have an increasing order of deviation. You can see red first, you have red, followed by green, you have green, followed by blue. So option A becomes the correct option. Red, green, and blue. Roy Gibb. So Roy Gibb. So that's what you are to what? Put in your mind under dispersion of light. Here you have gas laws. The question here tackled gas laws. Let's look at another one. Can I clean? Okay. So we're looking at another question quickly. Please pay attention to the explanation. These are questions that require you to understand the nitty-gritty of what you are picking. In terms of what? Deviation. We are saying the deviation is increasing along the arrangement of Roy Gibb. So put that in mind. The next question. The next has this to say. I, that's number 3 now. You have Roman figure 1 says rays of light travel from a less dense medium to a denser medium. I has this to say. The angle of incidence is greater than the critical angle. Last but not the least, rays of light travel from a denser medium to a less dense medium. And the question has this to say. Which statements above are conditions for total internal reflection? So A has this to say. Is it I and I only? Option B says, is it I and I? Option C says I and I. And option D says I only. What conditions are necessary for total internal reflection to occur? The first one is saying that rays of light have to travel from less dense medium to denser medium. We have option B saying the second tag says the angle of incidence should be greater than the critical angle. The last has this to say, the rays of light travel from a denser medium to a less dense medium. This is only asking you to differentiate between refraction and reflection. What's the difference between refraction and reflection? We have, refraction and total internal reflection. So we have that under refraction, for refraction, it's always such that for refraction, you have light from less to denser. You have that under total internal reflection. Under total internal reflection, you have light moving from denser to less dense. So in this case here now, this first guy is emphasizing refraction. This last side is emphasizing total internal reflection. This side is emphasizing TIR, total internal reflection, from denser to less dense. This second one is emphasizing CIR. Have this at the back of your mind. You have critical angle under the topic total internal reflection. Critical angle is under total internal reflection. And what other question do you want to put in mind? This, you can find it under your practical question. When you're having practical sections, they can ask you that what are the conditions for total internal reflection to occur in your physics practical. But since it is UTME examination we are talking about, you have this as what? Optional questions, whereby you have your Roman figures and you're expected to pick exactly the correct one. In this case here, CIR applies to option 2 and option 3. That's why we have that what? For the above, option 2 and 3 are the correct answers. Total internal reflection would occur when you have the angle of incidence greater than the critical angle. Also, it would occur when you have rays of light traveling from a denser medium to a less dense medium. Bear in mind that to now calculate your critical angle, they can ask you to calculate critical angle. Then you are working with what? Refractive index under TIR has been equal to 1 over sine C, where C equals critical angle. Bear that in mind. You can be asked to calculate your critical angle. Then you should know that what? The refractive index they are going to give you inside that question should be equal to 1 over sine C. This is the formula for total internal reflection in relation to critical angle. We move on. So, what will be the next question? Let's have it. Interesting. Here, for those that are familiar with kinetic molecular theory, this is for you. Kinetic molecular theory. We are told, number one, Roman figure 1, it is rapid. It is a rapid, constant, and irregular motion. Of tiny particles. So from biology, you can figure out this. Also, chemistry. This, I has this to say, it gives evidence. It gives evidence that tiny particles of matter called molecules exist. You have it that it takes place only in gases. It takes place only in gases. And number 4, you have that it gives evidence that molecules are in a constant state of random motion. So here we have the four options. It's for you to figure out which one applies to the topic in question. And from the look of things, mere seeing these options, it gives you an idea of what exactly we are talking about. It gives you an idea of exactly what the question is all about. And you know for a fact that it is under the kinetic molecular kinetic theory of gases. Now, in this case, the question is now asking us, which combination above is correct about Brownian motion? Which combination above, which combinations above is correct? Which combinations above is correct about Brownian motion? So we have A saying I, and I. B says I, and IV. C says I, and IV. D D says I, and IV. So here we go. Which of the option do you think is wrong? Remember, they play on your intelligence, asking questions, and they make minor twists to what you have. Here now, almost everything is looking correct.